So today we'll be discussing regarding two-page commit. So what is the advantage and what is the disadvantage of it? Why it is required, and then what is the alternative to the two-page commit for the distributed transaction or distributed environment? And we'll go for case by case in details, right? So let's talk about two-page commit exactly. What it is. So when distributed components or distributed environment, or when you have a node, let's say here one node, here one node, here one node, and here one node. Let's say there is four, or let me consider five in the best case, right? So you have a five node in maybe different region. So maybe US1, this is in Singapore, or this is some other reason, right? So let's say in application you are making a transaction. So now you want to commit to your database. Okay, so how you'll do it, right? So to bring the consistency or the atomicity into this transaction, so we have to save this exact transaction to all the available nodes. Like it is a node 1, node 2, it's node 3, node 4, and node 5. So everywhere you have to save the same transaction without a failure. So how we could do it? So there are many ways to do it. So today we'll focus about two-phase commit, how it exactly works. So in this, so there will be a coordinator and there will be participants, right? So let's say out of this five node, how you could do it, right? So let's say, so what happens exactly in this? There is a two phase. There is called pre-commit phase and another is commit phase, right? So pre-commit phase is here. Like this part is, sorry, I missed it. So pre-commit phase is here. Pre-commits right? And this is the commit phase, right? So what exactly happens here? So the moment coordinator receive a transaction, new transaction, let's say T1. So then it's asked to all participants, all nodes like node 1, node 2, node 3, node 4, node 5, node 4, and node 5. So everybody, all the participants, right? So are you guys ready to commit, right? If they says, yes, I am ready. Yes, I am ready. Yes, I am ready. So yes, I am ready. Yes, I am ready. So everybody once they says, yes, we are ready to commit, then only, the coordinators will say, okay, now you commit it. Now you commit it. Let's say anything gets fail in between. Let's say there is a, so it's got an instruction, there is a failure, the node 3, what is it, node, okay, let's say node 3 got failed to commit this transaction. So what will happen now? Now you have to completely roll back all transactions. You just roll back all transactions. So if you'll majorly, if you'll see what is the disadvantage would be like, blocking nature, single point of failure. Because if you see, coordinators get failed means everything will be get stopped, right? Like blocking in nature, the coordinator fails after the initiating the transaction. Participants may be left in the blocked state, right? Yeah, that's true. And let's say blocked state generating indefinitely. If similar way, like in a single point of failure, like in the coordinator is a crucial component, which passes. Same thing what I explained in the last minute, if anything happens, right, the coordinator, the entire transaction gets stops. That's again another problem. Then there is a network partitions. If any networks, like let's say if it's US1 or Singapore, maybe in Singapore there is some issue with the network. If anything goes wrong with this network partitions, then your whole transaction will get stopped. So what we could do to come out of this? There are many things we could do it. There is the one solution what I could think of at this moment that is called Saga Pattern in the microservices architecture and in these distributed transactions, right? Or distributed systems. So what exactly it is, right? So what happens, okay, when you have this kind of rollback, there's high chance, a two-page commit gets successfully at the, very high transactional computational system, right? Because when you get like, let's say, beyond your capacity or sometime, in high load time, this two-page commit might get failed. There's high chance. To come out and you have to roll back all the transactions, which is very pathetic. because you have to, by meanwhile you're rolling back, there could be some new transaction. How you'll handle that? That also you have to look for, right? You bring a lot of complexity if you go for the two-phase commit, right? So to simplify this, we have a Saga pattern, and so as I said, there could be many solutions, but this is the solution what I could suggest, and we'll discuss it in this video. On the future video, I'll discuss the other option what we have and how we can implement in the microservice architecture and distributed system, right? So this largely the Saga pattern has two methods. How you can implement this? That's called choreography model, and that is called orchestration model. The choreography, exactly how Saga helps. The whole motto of Saga is like, let's say in this, you make a transaction, you do completely roll back the transaction, right? But in Saga, you don't have to do that. If anything gets failed on chain of transaction, at any instance, if just transaction get failed, so you have to revert or just compensate the last successful transaction. You don't have to completely reward it. Then what you could do? Then you could retry that. You could retry with music, and maybe you could retry a couple of times. The ideal way would be retry for 3 times. If it's not get successful, then put into the log system and reply to the system owner. Then developers like, this is the critical issue. Please have a look. You could just channelize this kind of error into the Elastic server with Kibana, or could be Slack, or could be the SMS notifications, or it could be a direct urgent call to the system owner, right? To notify them exactly there is a serious issue comes to save this transaction. So then they could exactly trace down. And there is a difficulty in two-page commit also to trace down exactly what's happened, how to recover. There's no way. There's very difficult procedures, which is very complex to monitor, and that's the issue. But in Saga patterns, you could fix it very easily because you have a very complete shout. You could do it, you could trace it, and you could see like in which point the transactions got failed, what is the reason, and how many retry happen. After that, why it's not got successful. Then you could see that in Slack or the Elastic front end would be Kibana. You could see all these details, and you could just get the patterns of it, right? And basically you could follow the principle. What do you do follow for to do a share, right? You find the pattern, and then you just lodge a ticket for the developer to take it down for the development, right? Or to fix the urgent issue. So in this scenario, like so basically Saga pattern is 2 types. One is choreography based approach for event driven, and one is orchestration, which is a completely centralized one. So what exactly to use this choreography based approach? So see, let me give you an example. I think first I should explain this orchestration based approach, the centralized one, right? So see what happens here. This is the Saga logs, right? Logging system. So what happens, like let's say you started transaction 1, goes for the create order, right? Create order, and then Saga pattern start here, then it's create the order. Then transaction 2 comes, transaction 2 the process the payment, it happens here. Then transaction 3 come here, so it starts and end here. The transaction 4 comes here, it start here and end here, right? So any point, let's say it's get fail and the transaction 2, the process payment, then what will happen here? Again, it will create, let's say, process payment, it will retry it, right? Let's say it's retry for 3 times. Then if it's not getting successful, then probably we can log into Elastic or some logging system, and it will notify to the owners. So for this, you don't have to revert complete transaction. Just to take an example, like, let's say it's get fail around on this final stage. What you have to do in two-phase commit? You have to roll back the complete transaction, right? But in this case, in this scenario, you don't have to do it. You have to just roll back this transaction to put it back. And then you just retry it. Then you retry this method again. You just retry the method again. But there are a couple of drawbacks with this centralized approach. So what are them, right? So before that, I want to explain like when to use these complex multi-step workflows. If you have numerous steps to iterate dependencies, right? And then you can use this. Clear global view require like when stakeholders or architects need to well-define single blueprints for the entire workflow orchestration. Easier maintaining and debugging it. This is really it's easier. Potential drawbacks if you say it's single point of coordinations and tight coupling, risk of the over centralization, right? You can see there is one thing here. Everything is very much like process payment is very much dependent on creator order, right? It's very much dependent, and this is very dependent on this, right? And the delivery order also dependent on the update inventory, right? So very much tightly coupled. These are very much centralized control and single point of coordinations, right? So that's actually a lot of things. Like if everything goes here, so there could be issue. So to simplify this is a methodical choreography based approach, which is event driven. So when to use it, if it is your like your workflow is very simple, let's say 4-5 steps or 4-5 transactions, then that would be good. So your transaction size is high and number of transactions also high in a single then that could be issue for this choreography based approach or the event driven. You then probably go for like orchestration based approach, which is completely centralized one, right? And it's highly decoupled microservices. Why? It's not depend on anything, a coordinator kind of things. Like order service exposed to the event one, like payment event, it's created order event, inventory event. So it will just put into the kind of Kafka message broker that this event need to fire it. Order service will just fire this event, right? Then this event will be consumed by the consumer side and they'll do the all operations. And to doing this asynchronously and using the message broker, the third party provider, it's bring very smoothness and the transaction is very smooth. Yeah. Comparative to this orchestration based approach, a centralized approach. So when to use choreography and when to use orchestration, right? That's a big thing. So see, when you're looking for a decentralized system or the so basically, if you need a decentralized commit in a distributed system and you want a kind of Saga pattern, probably choreography would be the best option for you. If you need a centralized, very complex one, then it could be orchestration would be the option for you, right? So if you need a scalability, then choreography would be a good option for you because a lot of things happens with the asynchronous, also with the message because, and you just have to publish your message. There will be consumer, and it will see if anything goes wrong. There could be multiple retries and it goes very smoothly. Okay, and there is not moderate. But in the orchestration, you have a moderate. You have a kind of somebody to moderate how the transactions are happening. Transaction 1 is completed or not. Transaction 2 is completed or not. Transaction 3 is completed or not. A final transaction also not completed or not. If not completed, then revert compensate the last successful transaction, right? So if you need a moderate system or the kind of centralized system or tightly coupled system, then probably Saga orchestration would be the ideal solution for you. So let's say in the complexity side, choreography event driven architecture is very simple workflow, but the orchestration is very completely complex workflows, right? Very complex because it's need to monitor each steps of your transaction, what exactly happening. Like let's say here, you don't have to do so because once you publish to the message broker, you don't have to do it. So then the consumer will take care from the message broker, right? So you're just breaking the dependencies. Everything is loosely coupled. One service is not depend on the other service, right? But here, one service is depend on the other service. As I show you, the create order completely depend on the process payment. Process payment completely depend on the update inventory. Update inventory completely depend on the deliver order, right? So this transaction has to be in sequence, right? Yeah. So this is what I wanted to explain, or this is what I want to teach you in this session. Thank you. Have a good day. Thanks for watching.